Okay everyone, today I'm going to be showing you something called the reverse Cartesian diver. And your goal today is to try to figure out how it works. So on the right here, I have a normal Cartesian diver. And what this is I have a glass tube here filled with water and there's air in the top here. Put it back in. And you can see that it floats in there. But now watch what happens when I compress the bottle. As soon as I put some pressure on it, the diver sinks. And when I let go, it goes back up. Squeeze it, it drops down, and let it go, and it floats back up. Now the Cartesian diver you may have seen before, but today I want to show you something even more amazing. This is called the reverse Cartesian diver. The reverse Cartesian diver starts like this. See how it's now on the bottom of the bottle, but when I give the bottle a squeeze, it goes to the top now, and let it go, and it falls back down. So you can see the two compared. Here's a normal Cartesian diver, and then here's a reverse Cartesian diver. So how is the reverse Cartesian diver working? Is this made of some different type of liquid, maybe some different type of gas bubble in there? So without skipping ahead in the video, if you're brave enough, why don't you go ahead and try to guess how you think the reverse Cartesian diver is working? So now you can see the reverse Cartesian diver at the bottom and the normal Cartesian diver at the top. So when I squeeze it, this one drops and the other one stays at the bottom. When I let it go, it goes to the top. But now watch what happens when I squeeze it really hard. Now the reverse Cartesian diver goes to the top and they're both up there now. And then as soon as I let it go, it drops. But then if I just squeeze it a little bit, the normal Cartesian diver drops to the bottom. So how is this working? How can I control which one floats and which one doesn't? Well, in order to answer this question, let's see what happens to both of these when I put it in the vacuum chamber. Okay, so you can see we have both of the floats in here. The one that has less water in it and more of an air bubble is floating at the top. The one that has more water and less of an air bubble is now floating at the bottom, or sunk at the bottom. But watch what happens now when I start to vacuum out some of the air in here or decrease the pressure around here. Okay, 3, 2, 1. You see that? Then let the pressure back in. So you can see I basically have a knob to make this one float. If I vacuum out the air, it goes to the top, but if I let it back in, it goes to the bottom. So let me zoom in to show you what's happening here. So now look at this bottom one and look at the size of the air bubble in there change. So I'm going to vacuum it out now. See the air bubble get bigger? So look at the size of the air bubble in there now. So this is the reverse Cartesian diver and this is the normal Cartesian diver. You can see the only difference between them is how much air is in there. When I let the pressure back in, now that one sinks because the air bubble size in there shrunk. So what I was able to do in my vacuum chamber is to change the size of that air bubble in there simply by changing the pressure of the air that's around them. Well, in this situation, we were changing the air pressure around it by using a vacuum pump to suck out the air. But when I was doing it in the bottle, we were changing the air pressure in there a different way. So in this situation, the way I was changing the pressure is by putting force on the bottle. When I compress the bottle this way, it changes the volume of the bottle, and the volume of the bottle gets smaller, and there's the same amount of air in there, so that means the pressure had to increase. And so if I increase the pressure, then the size of the bubble in the Cartesian diver gets smaller and it sinks to the bottom. The size of the bubble in the reverse Cartesian bubble also gets smaller, but it's already sunk to the bottom. You can see when I push on it, see the volume of the bubble change. And I let go, it goes back to the top because the bubble got bigger. If I squeeze the bottle a different way, I can actually increase the volume of the bottle. So if you squeeze it this way, the sides actually pop out and it makes the volume of the bottle bigger. And when the volume of the bottle gets bigger, there's the same amount of air inside, so that means the pressure of the air had to decrease. And so that means the bubbles get bigger in both of them. And this one's already floating, so it just stays floating. But this one is sunk down, and if I increase the size of the bubble in there, then it starts to float. So the way it worked in the bottle is, when the bottle is just at normal pressure, it's a rectangular shape like this. And in this case, I just used a Listerine bottle. If I squeeze it from the front, then I actually decrease the total volume of the bottle. So that makes a higher pressure. So the bubbles of both of the Cartesian divers get smaller. But then if I squeeze it from the sides, it actually increases the volume, so the bubble gets bigger inside, and it causes the reverse Cartesian diver to float. So you can see it clear when I do it in a glass tube with an elastic top like this. So all I have to do is push on the elastic top, and it'll change the volume of that bubble there, and it'll sink. The volume of the bubble is going to get smaller. And it sinks. Then when I let it go, it comes back up. So see when I change the volume, it starts bouncing up and down. So this time, instead of pushing down, I'm going to pull up on it like this. So when I pull up on it, here's what the bottom one does. Hey everyone, thanks for watching. Consider subscribing if you haven't subscribed yet, and check out theactionlab.com to see the Action Lab experiment boxes where you can do experiments similar to what you see me do on my channel. And thanks for watching, and I'll see you next time.